very inefficient, but really cool. All right, then you have, besides this maker board box systems, you have things like these, the small-scale helicopters, these node-copters that can be controlled through Node. You know, you see this hardware prototyping coming from the microcontroller world or the small-scale computing world, and building into actual production-level devices like these copters. Being able to control them through the internet, through a phone, etc., and being able to program them with Node. It's just really cool that we live in an age now that we have this technology that we can build anything we want. And that's the coolest thing, and because we started with a lot of software engineering, and we were kind of closed off on what we could do. And the software engineering revolution on the web happened years ago. But now, this open hardware has released a whole new set of things that we can be involved in. We can basically change anything around us. So one of the coolest things that I've seen are people taking small little microcontrollers, even smaller, that big, with, let's say, an accelerometer on it to measure movement. And they can do things like tie it to a chair, and when the chair moves, someone pulling it out to sit down, it can actually measure that as someone sitting on the chair. So you attach these to in an amphitheater, for instance, and every single chair has one of these little devices. So every time someone goes and sits down, it marks that one as in use. So now you have a visual way of determining where seats are. Now that's just one thing that you can do, but the sky's the limit with these systems, because the microcontrollers continue changing and they're all open source, just like the open source software industry, which makes it interesting to work on. And that's a really good transition towards one of the first parts that we want to talk about, and that's the internet-controlled hardware aspect. So we're going to focus a little bit on the Arduino system. With a lot of the boards out there, you can add Wi-Fi capabilities through Wi-Fi shields, Ethernet shields, and just tack them on. Essentially what you would do is you would have your board like this, and then let's say I have an Ethernet shield to have Ethernet capabilities. I would put a little board on top of here. You would sandwich the boards together, sitting through the pin systems. So it's essentially just stacking and stacking. Eventually you have a nice little board like that. And that's typically what you would run off of, and put your sensors on top, like a humid sensor or any moisture sensor or anything like that. But I don't like that type of inefficiency of throwing hardware after hardware on top of that, because it looks ugly and it doesn't fit within nice little cases. So there's actually some really nice hardware that allows you to start working with web capabilities beyond something like the Uno, which is the standard board out there. The Arduino Uno came out about a year and a half ago, or something around that. And it's a little bit more expensive than some of the standard boards, running at around $65 to $70 as opposed to the $35 to $40 of the Uno. But it has several capabilities built in for actually working with a lot of internet-controlled hardware. It's probably my smart board that I use, I guess you could call it. My Unos are my worker bees. I put them in any sort of hardware that I want, if I want to test out anything that has neat internet capabilities. If I just need to work on, let's say, straight C and throw it up to a board, I'll use a Uno. But every time I need Wi-Fi capabilities, or I need any technology capabilities of leveraging off of API data through a microcontroller, this is the board I use. So I have dozens of Unos and 3 of these. Now, the one thing I should mention, actually 2 things I should mention about this board is potential gotchas. First, they're hard to get most of the time. They come in batches. So right now, I believe a new batch has been released. They're easier to get, less expensive. You can probably find them on basically any online shop and any online maker shop, and just buy them that way. But they do sell out. In fact, I had bought my first 3 right when the first batch was released, but then I tried to buy more for my team, 5 or 6, and I got on this wait list for 3-4 months. That's one. First gotcha. Second gotcha. The Wi-Fi built on board is a little bit tricky once you set it up. So once you set it up to a Wi-Fi, resetting it to another Wi-Fi can be a little bit tumultuous. Figure 15 to 20 minutes of work just to get it working. It's really not complicated, it's just kind of a pain when the Wi-Fi reboots and having to recontrol it. Alright, so some of the feature sets that we're working with this board on are web service integration with a company called Tembu. Tembu was one of the partners on this initial board type. When they were building out the architecture of the board, they wanted their system integrated into it. Really what they are is an abstraction layer for APIs. So working with Tembu overall, you can access basically hundreds of different APIs and just work with their system as opposed to working through the documentation and the application review process of every different system out there. So you're using one technology built in, and they're built directly into the board out of the box, so you can start working with them. That means easy access to APIs. Then you have Python 2.7 installed with the Linux integration. So it's basically running this OpenWRT Linux distribution on the board. That's what powers it, and it has Python 2.7 built in. Again, you can really work with any language you want through these kind of bridging technologies that we're going to talk about. But if you want to work directly with Python on the board, that's the way to do it. And then finally, integrated Wi-Fi and Ethernet. So Wi-Fi is right around here, Ethernet capabilities on the back here. You can power the device externally, so let's say right now it's hooked directly into my computer to power it and to upload the programs to it. But essentially there's this pin on the side for bin and then ground. These are the two you have to look at when you are actually powering the device with a, let's say, an 8-volt battery. You want to keep the power to it about 7 volts, otherwise this 5-volt connector, which is basically where all the electronics hook to, servo motors, these LEDs, things like that. That's what powers it, so if you don't have above 7 volts, it won't work properly. It'll run underneath 5 volts. So that's just one thing to note. So what you would basically do is take a battery, and then you have a connection on top of the 8-volt battery, and you would connect the power into VIN and the ground into ground. So that's how you power it externally if you want to run it off a battery, which most of these boards, once you actually put them into practice, that's what you want to do. Alright, so one of the other things on the Tembu side, which is actually great for people getting started, now how many of you are software or web developers? Well, most of you. Designers? Yeah, a number of you. So this is really cool if you're coming from the front-end engineering and design aspects. We're starting to work with these boards, especially the Yum. At Tembu, we were running a meetup on the Arduino Yum in Miami in January, and they just launched this sketch builder, the Tembu sketch builder. And how many of you here have worked with Yahoo pipes before? A number. Okay. It's basically like taking API data or components. Now, let's think of it like components of the board itself, like the Ethernet capabilities, or the particular digital pins that you can run power off of, and allowing you to control that visually and attach them together. So you're basically creating a schematic diagram using the sketch builder of how the program should run. And once you compile that, it compiles down, it uploads to the board, it compiles down to machine code to run the actual board, which means you don't have to touch a single line of code. Awesome for getting started, because it helps you understand how the boards work and how the connections all work, which is really, really nice. And then you can start playing around with it, but that's a really easy variant entry that you can bypass. So the first thing that you're going to need to do in order to work with the Arduino Yum as we're working through it is fetch the Arduino IDE. The Arduino IDE looks like this. So it's basically just your programming shell that you would actually build all of your programs in. So this one in particular is a PayPal integration, which we'll take a look at in just a second. Utilizing Tembu, so it's basically leveraging off the API. But when you're actually going to the download link, you go to this website, and you're going to see the first stable release, the 1.0.5. For almost every single board out there, this is the one you use. It's stable, it works well, there's no problems. For the Yum, we do not use this one. You go down to Arduino 1.5.6 release candidate 2 beta. Awesome. It's like saying big letter experimental alpha. But it actually works really, really well. I have not had any problems with it whatsoever, but it has the capabilities for the board. So this is the one that you're going to want to download if you're working with the unit. Oh, and those nightly builds? I would tend to avoid some of those. It's like using the Firefox nightly builds or any other like Chrome nightly builds. You're going to get the most effective, newer technology, but it can go down. All right. So you're going to fetch the Arduino IDE. That's how you're going to program right off the bat. This is not the JavaScript layer yet. This is just controlling the board. Then you have to enable the board in the IDE. So you'll go to Tools, Board, and then select Arduino Unit. So that's going to actually select the board. You have to do this for any single board that you're actually going to be working with. You select the one that it's going to work with. And as you can see from that list, there are a lot. Next, you're going to select the port that you're going to actually communicate with. So it's basically this USB to mini USB connector here, or through the Wi-Fi. So you would select port. You need to connect the device before doing that. Otherwise the port won't show up, and you'll select USB modem underneath that list. So just quickly on that one, just to show you what it looks like in actual practice. Zoom in a little bit. You go on Tools, Board, select the unit. So that's the first step, and then once you connect it, you go to Port and select your port. Now once you set up the onboard Wi-Fi on this, you can actually communicate with it via a Wi-Fi connection. So there's multiple different ways. You don't have to plug it in directly. Alright, so now that we have that in place, let's go through an actual integration. So this is where, I swear this is the only time I will deal with the C code and work with it, but I want to show you how it works out of the box before we jump into the node integration, so that you actually see that the node integration is so much easier than anything that you're going to deal with straight on C and working directly with the board.